What's up everybody, welcome back to another video. Today we'll be learning about dividing polynomials. Now, dividing polynomials is a harder topic for some at first, but once you actually understand the steps and method to go at it and get to practice with it, it will definitely make more sense and it will be easy to do. So in today's video, I'm going to walk you through an example in which I actually show you the steps and methods to go at it for dividing polynomials. And then I'll give you guys the opportunity to try a couple examples on your own. So let's begin today's lesson with that example. And here it is right in this image. We're dividing x squared plus 11x plus 10 by x plus 1. Now, here's just some vocab words per se to use in terms of division. It's so good to know that this term right, or this polynomial right here, x squared plus 11x plus 10, is known as your dividend. And right here, this polynomial, x plus 1, is known as your divisor. And as everyone knows, your answer, which we have right here, is your quotient. So we have our dividend, divisor, and quotient. And that's just something to know when you're using long division. And as you can see by this image, long division is the method we will be using for dividing polynomials. Now, it's not as easy as it was for just dividing whole numbers and normal integers such as 4 and 3. It's a little bit more complicated for polynomials, but as I explain it to you guys, hopefully you will understand how to do it. So, as you can see, the main thing to understand when dividing polynomials by using long division is you want to cancel out these terms, and that's basically what we necessarily do in a long division too. Starting from the left to right, we want to get rid of each term so that we result with possibly a remainder of 0 or just a remainder. So as you can see in this example, the first term we want to get rid of is x squared. Now to get rid of that term, we have to multiply our divisor right here by a certain term or number that will give us a result which we can use to cancel out this x squared. So right here in this example, we see that we multiply x plus 1 by x first. Well, x plus 1 times x gives us x squared plus x. Okay, that makes sense because now we are resulted with an x squared which we can use to cancel out this x squared in our dividend because we want to get rid of all of these terms. So, but there might be something a little confusing for you guys, and that might be, well, if we have x squared plus x, how do we end up with minus x squared minus x over here in our next step? Well, it's easy to think of it in terms of distribution. So first, we would have actually our x squared, our positive x squared, plus our x right here. That is what we got from multiplying x plus 1 times x. But you see, we're subtracting this. We're subtracting x squared plus x from our dividend, and we will subtract that. We want to kind of put parentheses around it and distribute this negative sign. So when we do that, we get minus x squared minus x. And it's only like that since we're subtracting when we're doing long division. So all you need to know to think of it the easy way is when you get your answer right here, for example, when we get x plus 1 times x equals x squared plus x, just reverse your signs for each term. So positive x squared would become negative x squared, and positive x would become negative x. So as you do that, we can move on to the next step where we actually cancel our terms. So x squared plus negative x squared is just 0. These two cancel out. And then we get positive 11x plus negative x, which is 10x. Okay, cool. We canceled out our first term in our dividend, which is x squared. Now let's cancel out our next term, which is a 10x. We want to move from left to right and just cancel the terms with x's in them. Because as you can see in our polynomial, the biggest x term we have is x to the first power. So when we get rid of the x to the first power in our dividend, we can just find our remainder. So now what do we want to multiply x plus 1 by to get 10x, to cancel this term out? Well, as you can see, we multiply x plus 1 by 10. Well, x plus 1 times 10 is 10x plus 10. And as you can see, that makes sense because, remember, we're subtracting this from our dividend. So we actually reverse the sign, so this would become a negative 10x, and this would become a negative 10. And as you can see, we have a positive 10x right here. So if we make this a negative 10x, these two would cancel. And in addition, these two cancel as well, our positive 10 and our negative 10. So that gives us a remainder of 0 actually. And over here, we have our answer, our quotient. So that's basically how you do long division for dividing polynomials. You just want to go from left to right in your dividend and cancel out the terms and end up with the possible remainder. It won't always be 0. Sometimes, or usually, it will actually be a number. And as we get to a part where we actually get a remainder, there is a way you have to write it. There's a format for your answer, and we'll discuss that. But hopefully you understand the sort of method we use long division for dividing polynomials and in what way to go at it. So now that I've walked you guys through the example, let's go on and we'll move on to the first example that you guys will actually try on your own. And feel free to pause the video if you do want to try it on your own, but it's completely fine if you want to just watch me do this one too. And here it is, our first example that we're going to do on our own. X cubed minus 4x squared plus 2x minus 3 divided by x plus 2. So let's write this in our long division format real quick. So we have, let me start a little bit lower. We have x plus 2, our divisor, and we're going to put right here in the division sign, x cubed minus 4x squared plus 2x minus 3, which is our dividend. And then we want to get our answer, our quotient. Okay, well, judging from what we did last time, let's get right into it. Remember, we want to get rid of the terms left to right, so our first term is, in our dividend, our first term is x cubed. Well, we can just think of it simply in this way. We want to look at our x term in our divisor. We want to look at our x term and see what can we multiply x by to get x cubed. Well, x times what equals x cubed? Well, x times x squared equals x cubed. It's just as simple as that. So over here, our first term we'd multiply our divisor by is x squared. So x plus 2 times x squared gives us x cubed plus 2x squared. And remember, since we're subtracting, we want to reverse our signs, which would give us minus x cubed minus 2x squared. Okay, cool. So now these two terms would cancel out, and then we would have negative 4x squared plus negative 2x squared, which is negative 6x squared. And we'd also bring down our plus 2x and minus 3. Okay, cool. We got rid of our first term, x cubed. Now let's move on to our next term, which is minus 6x squared. Okay, well, basically, once again, we want to look at it in the same way as we did for our x cubed. X times what equals negative x squared? Well, it's just negative 6x. X times negative 6x equals negative 6x squared. So that would be our next term in our answer, minus 6x. So x plus 2 times minus 6x equals negative 6x squared minus 12x. So let's go on to the next step where we reverse our signs. Remember, since now we actually have negative signs for the 6x squared and 12x, we would reverse those signs, which would result us with plus 6x squared and plus 12x. So now these two would cancel out, and we would have 14x minus 3. And now we just want to get rid of our last term with an x, which is 14x. So x times what equals 14x, and that is just 14. So we would add 14 right here. So x plus 2 times 14 is just 14x plus 28. Remember, we reverse our signs, and then we get minus 14x minus 28, which would cancel these two out right here and give us a remainder of negative 31. And there we go. We have our answer right here, x squared minus 6x plus 14. That is what you get when you divide x cubed minus 4x squared plus 2x minus 3 by x plus 2. But wait, we actually do have a remainder here of negative 31. So that means there's an actual format we have to write our answer, and here it is. This is the format you want to write your answer for polynomial division when you do have a remainder. And that would just be our actual answer, our quotient, which is x squared minus 6x plus 14. And to that, we want to add our remainder of negative 31 over our divisor, which is x plus 2. Which means our actual answer for this polynomial division problem would in fact be x squared minus 6x plus 14 plus negative 31 over x plus 2. Now, just to make it so you guys can understand, for our past examples, when we do have a remainder of 0, let's try putting 0 in for negative 31. Well, 0 over, for example, x plus 2 is just 0, and then x squared, and then since it's a 0, we don't even have to add it. So that's why we don't need this part for our answer when we have a remainder of 0. But when we do have a remainder, we want to set it up like we did in this. So hopefully you guys at least got this part of the polynomial division right, the long division part. But it's totally fine if you're just trying to pay attention. But I would recommend that you do try the next one on your own. So if you would like to do that, feel free to pause the video and have at it. And here's our last example, which is 3x cubed minus 2x squared plus 5 divided by x plus 1. So if you guys do want to try this one out on your own, feel free to pause the video. Okay, let me do this one for you guys. So right here, we want to set it up in our long division format, which would be x plus 1, our divisor. And then over here, we would have 3x cubed minus 2x squared plus 5, which is our dividend. And we want to find our answer, our quotient. So once again, let's do this fast. We want to get used to it so we can understand how to do it better. And we just want to see x times what equals 3x cubed. Well, x times 3x squared equals 3x cubed. So that means our first term for our answer would be 3x squared. And you just got to get used to thinking x times what equals the first term. You got to know what it has to be. That's how long division does work. So now we want to multiply x plus 1 by 3x squared, which would give us 3x cubed minus 3x squared. But we once again reverse the signs, which would be minus 3x squared, or minus 3x cubed, plus 3x squared. So these two would cancel out, and then negative 2x squared plus 3x squared is minus x squared to the 5th. Okay, so now we want to see x times what equals negative x squared? Well, x times negative x equals negative x squared. So that means our next term right here would be negative x minus x. So x plus 1 times negative x equals negative x squared plus x. It's basically plus 1x, but 1x and x are the same thing. So now we want to reverse our signs, and we would have plus x squared minus x. So that actually does mean we bring in a new term here. We get rid of the x squared, but we also now have in minus x plus 5. So now we just want to see, we want to get rid of our last x term, which is negative x. So x times what equals negative x, and that is just negative 1. So now we multiply x plus x minus 1 by negative 1, which would be negative x, and positive 1. We switch around the signs for that, and then we get plus x minus 1. And then after we do that, these two would cancel out, and then 5 minus 1 equals 4. So that means for this problem, our answer is 3x squared minus x minus 1 with the remainder of 4. So hopefully you guys wrote the proper answer in the right format, which would be 3x squared minus x minus 1 plus 4 over our divisor, which is x minus 1. So 3x squared minus x minus 1 plus 4 over x minus 1 is our answer for this problem. And hopefully you guys did get it right. So if you guys did enjoy this lesson or actually learn something from it, please feel free to drop a sub, and also check out our playlist on Math 2. Thank you for watching.